I have been given a question here, and the question comes from a topic called longitudes and latitudes. So the question is very clear. It states that there is an aeroplane that leaves a particular place indicated as point P on the globe. And we are told that this aeroplane ends up arriving at another point Q. So it actually ends up arriving at point Q from point P. So it departs from P and destinates or arrives at Q. We are told that the total time taken for this aeroplane to move from P to Q is 3 hours. And we are again told that the coordinate of P is 66.42 degrees north as its latitude and 30 degrees east as its longitude. So point P on the globe of the Earth is actually able to get given this. So the globe of the Earth has this point P with this coordinate, and this serving as our latitude, and this serves as our longitude. So the first point is always the latitude, and the second point is always the longitude. Always the longitude. The point Q is given the following coordinate: 66.42 degrees north and 52.5 degrees east. So I've said that this first point is our latitude and this second point is our longitude. So if you keenly look at these 2 points P and Q found on the globe or the Earth, you realize that they are found or they are located on the same latitude. So the latitude is the same, 66.42 degrees north, but the longitudes are different. So they lie on different longitudes. Remember, latitudes are those points or lines that run from east to west, and longitudes are able to run from north to south. So you can talk about west to east or east to west. Then longitudes run from north to south or south to north. If you actually look at this as your globe, this is the prime meridian or the Greenwich meridian. This is our equator, and any lines running from north to south or south to north, for that matter, are going to be called longitudes. And those that run from west to east are referred to as latitudes. So those 2 points P and Q are found on the same latitude but on different longitudes. So points getting found on the same latitude will always be able to get treated as points on a small circle. So these points are found on a small circle. So points on the same latitude are found on a small circle. And because we want to get the speed that the airplane moves with as it moves from P to Q, we shall be able to say speed is equals to distance over time taken. So then we shall say speed is equals to, what's the distance? Those 2 points are on the same latitude. So they're found on the small circle. How do I get the distance in nautical miles between 2 points on a small circle? I'll say 60 times theta times cos alpha. So theta is the difference in the longitudes. So the difference in the longitudes can give us theta. And we said that if the 2 points are in the same hemisphere, east-east or west-west, and you want to get theta, just get the difference between those 2 longitudes, either on the eastern part or on the western part of the prime meridian. So if this is our prime meridian and we have 30 degrees east and 52.5 degrees east, that means those points are found. This is the western region, this is the eastern region. So they are found on the eastern part of the prime meridian. They are all to the eastern part. So if they are found in the same hemisphere, east-east, or on the other hand, west-west, then you can just minus the 2 for us to get the theta. So you'll just come here and say 60 times our theta. I've told you they are found in the same region, in the same hemisphere. So just get the difference. So that gives us 20.5 multiplied by cos alpha. Alpha is the latitude onto which those 2 points lie. So they lie on the same latitude, which is 66.42. So cos 66.42 degrees. Let's place this in the calculator and then get the answer in terms of the distance between those 2 points in nautical miles. I want to repeat this. This point P and this point Q are on the same latitude. If found on the same latitude, they are treated to be on a small circle. For me to get the distance between them in nautical miles, if they are actually found on a small circle or on the same latitude, I'll actually say 60 times theta times cos alpha. 60 times theta. How do I get the theta? I look at their longitudes. Longitudes of these 2 points can give me the theta. I ask myself, are they in the same hemisphere or different hemispheres? They are in the same hemisphere. They are all to the eastern part of the prime meridian. What do? Just minus this from this. Then I'll be able to get the theta. So I'll just say 52.5 minus 30. That gives me 20.5. That becomes the theta. Times cos alpha. Alpha is the latitude onto which those 2 points lie. So our alpha is 66.42. So shall just come here and say 60 times 20.5 times cos 66.42. And that is going to give us the answer for the source. That gives us 492.036. So 492.036 nautical miles. So I just took 60 times 20.5 times cos 66.42. So 492.036 nautical miles. That is the distance covered by this aeroplane on moving from point P to Q, where those 2 points are lying on the same latitude, to mean they are found on a small circle, but they are found on different longitudes. So for me to get the distance first between the 2 points, I'll say distance is equals to 60 times theta times cos alpha. The formula of getting the distance between 2 points, if those 2 points are actually found on the same latitude or they are found on a small circle. Getting found on a small circle means they are found on the same latitude. But if points lie on the same longitude, they are found on a great circle. So 2 points lying on a longitude. For example, if I say 10 degrees north and 40 degrees west, this point X maybe, then I will say point Y is maybe 40 degrees south and 40 degrees west. That means the longitudes of these 2 points are the same. So to mean X and Y as 2 points in my case here are lying on the same longitude. If found on the same longitude, that means they are found on what you call a great circle. So if points lie on the same longitude, then that means they are found on a great circle. If points lie on the same latitude, they are found on a small circle. So the formula of getting the distance between them, if lying on a small circle in nautical miles, is 60 times theta times cos alpha. If I would have actually wanted to get the distance in kilometers between these 2 points, so distance in kilometers, I would just say theta over 360 times 2 pi r cos alpha. Theta will be now the difference in the longitudes, the same way I've actually done here. Divided by 360 times 2 times pi. Capital R represents the radius of the Earth, which is always given as 6370 kilometers, or 6371 kilometers, or 6400 kilometers. Always use what the question has usually given you. Then times cos alpha. Alpha is the latitude onto which those 2 points are lying. So this formula can help you get the distance between those 2 points in kilometers. If they lie on the same longitude and you treat them to be points on a great circle, we shall be able to get the distance in nautical miles by just saying 60 times theta. So there's no cos alpha. That's the difference between this and that. This is the distance in nautical miles between them. The distance in kilometers, what do I say? I'll still say theta over 360 2 pi r without the cos alpha. So the difference between the 2 points on a small circle and the 2 points on a great circle is the aspect of us having these formulae for getting the distance in nautical miles and kilometers for the 2 points lying on a great circle, not having the cos alpha. Now, they had asked us to get the speed that the airplane was able to move at for it to move from P to Q. So you know very well speed is equal to distance over time. So distance is 492.036 nautical miles. Then we're dividing this by the time, which is 3 hours. So just divide this by 3. So divide by 3. So it gives us 164.01. So we have to actually end up getting 164.01. That is nautical miles per hour. And this is equivalent to 164.01 knots. Because the speed of an aeroplane or a ship is measured in knots. And I know very well, 1 nautical mile per hour is equivalent to 1 knot. So 164.01 nautical miles per hour or 164.01 knots. So that becomes the speed that the aeroplane was moving at for it to move from point P to Q, taking 3 hours and covering 492.036 nautical miles as the distance between those 2 points.